Hi everyone, Marcy here. I am going to be doing the pre-session 2 with you on the 5 practices. And hopefully you had the time to read that article that we shared with you on the 5 practices. And now we're going to just dive deeper into these. This book actually really changed my life and changed my teaching. And so I'm kind of excited to share more information with you about this. So these are the learning objectives for this pre-session 2. You can go ahead and read through those. And as in pre-session 1, when you see that little journal and pencil there, take the time to jot down answers to the questions that we ask, or maybe just your thoughts or things that you're learning from this session. So in the article that you read, the 5 steps that a teacher can implement to facilitate this quality discourse, where they were just very briefly introduced to you. It talked about anticipating student responses prior to the lesson. It talked about monitoring the students' work and their engagement with the tasks that you select. It also talked about selecting different students' work and then sequencing those student responses in a specific order to facilitate your discussion. The last step was connecting the different students' responses and kind of connecting those responses to those key mathematical ideas that you have in your classrooms and to the goals that you set. So those were published in the first edition of this book in 2011. And then in 2018, the second edition came out, and the author actually added what is commonly referred to as step 0. So that goal is step is establishing the goals and selecting the tasks. So in this module, we're going to learn about each of these steps, and we're going to watch videos of these practices actually happening in a classroom. So the first one we're going to start with is step 0. That's establishing your goals and then selecting those tasks that will help you to accomplish those goals that you set. So what does it take to engage in this particular practice? This practice first requires that you set specific learning goals geared toward your standards, and then identifying a high-level task that's going to align with the learning goal that you set. This table on this slide highlights the components of this practice, and it also has some key questions that you can use to guide the process of setting your goals and selecting a task. So on this slide, you'll see some target ideas in that first column, and then there are 2 additional columns. Now, column A is what we consider to be a performance goal. So these performance goals will kind of just tell what we expect the students to be able to do as a result of engaging in a lesson. And in column B, that is more a learning goal. So contrast that to the performance goal. The learning goal explicitly states what the student will understand about the mathematics after engaging in that particular lesson. So that learning goal needs to be stated with specificity so that it can guide your decision making during your lesson. Just take a minute. You'll see the little icon down at the bottom of the slide. Just pause this video and think about how these goals are the same and how they are different in these particular grade levels. And then maybe, what do you think? Do those differences matter? Now pause just a minute and take some time to read through these quotes and maybe reflect on what you think about them. So now that we've specified the learning goal, the next component to step 0 is to identify a high-level task that aligns with that goal. High level tasks are also sometimes called cognitively challenging mathematical tasks, and they engage students in reasoning and problem solving. And the questions here on this slide will help you maybe decide if the task you're choosing is a high-level task. By contrast, the low-level tasks, those are tasks that can pretty easily be solved using procedures or just applying the rules. So we want to avoid those. We want to give our students the opportunity to really think and grow and reason. And it has been shown through a lot of research, most research, that embedding those opportunities for students to engage in high-level tasks on a regular basis, it ensures that those students are going to have higher gains than the students who are just engaging in low-level tasks. So these questions are really important as you're deciding which tasks that you will choose. Now, answering yes to all of these questions doesn't necessarily mean that all the students are going to engage in the mathematical practices, but as you get better at using the 5 practices that we're going to continue learning about, then the chances are that the kids will engage more and more. So now that we've identified a learning goal and we've settled on a task that aligns with that goal, now it's time to explore the next practice, which is anticipating. And this refers to anticipating your students' responses. When I've implemented this in my classroom, I've been amazed at the things that students come up with that I did not anticipate. So I usually just take a quick picture of those and remember them for the next time I teach that particular lesson or use that task. Another thing that I like to do is work with my peers and have my teachers in my school also anticipate how they would see it, and then I get more ideas. Besides just anticipating what our students might do, we also have to kind of anticipate how we will respond to what they're doing. So in Peg's book on page 37, this is what she said. Anticipating helps prepare you to recognize and make sense of student strategies during the lesson and to be able to respond efficiently. In other words, by carefully anticipating students' responses prior to a lesson, you will be better prepared to respond to students during instruction. So this is before we even do the lesson. We're anticipating, we're thinking about how we will respond. This becomes easier and easier the more that you do it. So the 3 components of this step are to get inside the problem, really think about the different ways that students might solve this task. The second one is planning to respond to the students using the assessing and advancing questions, which we'll talk about in just a minute, and preparing to notice the key aspects of the students' thinking right in the midst of instruction. So take just a minute to look at this question about Miss Tice's markers, and then think about at least 2 different ways that you anticipate your students may solve this, and then consider those questions on the left-hand side of your slide. Go ahead and pause this video and write your answers in your journal. So on this slide, there's several different approaches that can be anticipated. Did you come up with any of these, or did you have some that aren't anticipated here? Go ahead and look through those. Take your time and really delve in. So now we have those ideas about potential student solutions, and the next step is to think about how we're going to respond to those students. And there are 2 kinds of questions to be particularly useful in supporting this student work. The first one is assessing questions. You can see that there. This is a way to just draw out what students are thinking about a problem. And then it's also a really valuable way for you to investigate what a student understands or why a student decided to take a particular approach to this problem. And rather than just kind of infer what students are doing or thinking about their reasoning, you can really ask them questions so that you understand where they're at in this process. And then you can use that information to make better instructional decisions. Then there's also the other column, the other column that talks about questions that will help students kind of extend their thinking toward the lesson goal. So we want to press students. Once we know where they're at, then we also want to anticipate the kind of students that we can, the kind of questions that we can ask our students to kind of move them forward in their thinking and understanding. So during this anticipating stage, we will want to prepare some assessing and advancing questions. So this is like one of the ways that you can organize your thinking with this. You could look at each of those solution strategies that you anticipated students coming up with, and then thinking about those questions for each of those strategies. So what I'd like you to do right now is just in your journal, take 2 of those strategies that we previously saw on the slide before, and then think about questions that will help you to assess where students are. Questions just like, tell me what you did. You want to know what they did and why they did it. Try and understand their thinking as they were working on the task. And then write down a couple of advancing questions. How are you going to move them forward to get closer to the goal that you have in mind? So this is an example of an organizer in Peg Smith's book that kind of shows how you can lay this out. You can put the strategies and then your key questions, both the assessing and advancing questions. And then you can talk about who, and you can write notes about who and what is happening when with your students. And you'll do that during the monitoring phase. And then the next one will be done, the order will be done in the sequencing stage. So these first 2 boxes are really just this anticipation step that we're on right now. So on our next slide, you're going to be watching an example of a teacher in her classroom during this anticipation step.
Anticipating is the practice of determining in advance of the lesson what it is you think students are going to do, both right and wrong, as they work on the problem, and the questions that you're going to ask them to determine what it is they understand and to move them beyond where they currently are. And anticipating is really foundational to doing any of the other practices. You can't monitor, select, sequence, and connect if you hadn't given considerable thought to what students might actually do and how you would respond. The point of anticipating is to put the teacher in the position of not having to make every single decision in the moment, on the fly, but rather to have thought through many of the decisions before she ever set foot in the classroom.
With the anticipating, I already know, I have an idea of what students are going to do before it happens. Now, they might do something new, but at least I've already thought about it. I did the task myself, thinking about what we've done prior to. So I wrote down some different strategies, based 10 blocks, 100 charts. You know, the rounding to compensate, that's one of my goals, to get them to see that. So I put that in there. connecting the base 10 blocks to the equation. Some of them are ready to do that because some they can see it, but they're having trouble writing an equation.
Okay.
So I want to make sure I focus on some of those students.
Okay.
One of the things that teachers find particularly challenging about anticipating is moving beyond their own way of solving a task. So trying to put yourself in the position of how students would think about the problem, get inside students' heads, and really think about it from a perspective other than your own. This is very challenging work. So what we found is that when you work with somebody else, or a number of different teachers, or even give the task to different people and ask them to solve it, you will get many different ways of thinking about it that help expand your own perspective on the task and really prepare you for the kinds of things kids are likely to do.
What I found valuable about the 5 practices is really the anticipating and figuring out what the students might do so that I'm not stumped in class and I know exactly what to say to get them there and how to advance them farther in their learning instead of just getting stuck and saying, what did you do? Okay, and then moving on.
One critical piece of anticipating is creating a monitoring chart. On this chart, you would make a list of the strategies that you anticipated that students would use in solving the task, as well as the assessing questions and the advancing questions that you would ask students who produce those solutions.
The assessing and advancing questions helps me see where they truly are and being able to push them further. And then having them do most of the work without me telling them everything to do.
So did you come up with any misconceptions or errors? Or
Yeah, while using the 100 charts, some of my students, because we looked at patterns on the 100 charts, so some of them may try to add versus subtract. So I'll have to make sure that they see, look at your tens place. So what do you notice about the tens place? What's going on with the values?
talk about what are you going to do if a student can't get started?
If they can't, just refer back to the context. What's going on in the story? What do I have? Okay, what happened? Can you show me that with your manipulatives, your base 10 blocks? How many did I start with?
Okay.
So
I like how you started with you're going to ask them what do they know about the problem.
Right.
Okay. All right.
Okay, we are done anticipating, and now we get to take what we think the lesson is going to have and put it into action. So we're going to be watching a lot of videos throughout this monitoring section, but I do want to go over some of the things that you might be looking for. Yeah, I just want to point out real quickly that there are 3 main steps in the monitoring component of this. The first one is tracking the student thinking. And so you're going to think about what it was that you anticipated and then look for that in your monitoring. Then you'll also be assessing the student thinking using those questions that we thought about previously and advancing student thinking. So as you're going around, keep all of those things in mind. Keep those things in mind that you anticipated, and your preparation will definitely help you in this step. So some of the things you really want to think about in the monitoring step is how you're going to keep track of the things that you're noticing. I shared with you a little monitoring sheet from that book. You can create your own, but I would really suggest finding some way to keep track of what it is that you're noticing as you walk around. There's a couple more things that you might want to think about, like how are you going to wander the room? How are you going to make sure that you get to all of your students? And what techniques might help you more effectively track that student thinking? Again, practice makes progress with this step. So one of the most important things that you can do is just really look at what students are doing, try and figure out what it is that they're writing, and ask a lot of questions. That's how you'll find out, you know, what is this here? Why are you choosing to do it this way? Ask those questions so that you can get to the heart of their understanding. So the next slide is going to be a video, and it's going to be sharing some of these students and their work. You'll also see Jocelyn and Dewan's work here. So I want you to think about these questions as you're watching this. So what assessing questions does Ms. Tyus ask Jocelyn and Dewan? And how do her assessing questions help her to make sense of how they are thinking about the problem? And then how do her assessing questions help her diagnose those challenges that these students are facing? Think about those things and jot down your thoughts in your journal.
What do we got going on here? What are we doing? Tell me about your thinking.
So I put 60 tens. And I put
Wait a minute. You put 60 tens?
6 tens.
Oh, okay. Sorry. Thank you for clearing that up for me. Okay, you put 6 tens.
And 9 ones.
Mm-hmm.
And then I'm trying to figure out what is the answer. So I X out 4 of the tens.
Okay. So what made you think to X out 4 of the tens?
Because we're subtraction.
Oh. Okay. So the X means what?
Take away.
Oh. Okay. And so now you're trying to determine the answer? Oh. Okay. Go ahead and determine it, and I'll be back. So what we got? Tell me about what you have. Tell me about your work.
I got 69.
But wait a minute. What does that 69 represent? What is that?
Marcus.
Okay. And then tell me more.
I have 30 times and I got 29.
You have how many times? Can you show me how you counted that?
10, 20, 30. I got 29.
Oh, what were you just counting by?
Tens.
Oh. So now, how does this 100 chart, what is that? Or tell me about what you were doing here.
I put 60 tens and I put 9 ones and I got 29.
Okay, so I'm going to give you some time to practice. What I'd like you to do is I'd like you to look at this slide and look at JC's work and Leah's work, and then read those questions right underneath the journal prompt. Take some time to think about those, pause the video, and try and see what you would do at this point, knowing what you know about anticipating and monitoring. What would you do with that information? One thing to really think about is when you're asking those advancing questions, you can tell whether or not it's effective if those students kind of immediately jump into it and start to explore it. You'll know that you're doing your job with advancing right then. So take just a quick minute to stop and look at Elsie's work and decide what you can infer about what she might be thinking about this task. Sometimes it's really hard when you look at student work to kind of figure out what they're thinking. Can you look at Allison's work and think about how she's thinking about this task? And if not, what are some questions that you might want to ask her? Just go ahead and jot those in your journal. So as you watch this next video, you might want to consider what advancing questions that Ms. Tyus is asking the students and what were the goals of those advancing questions that she was asking. You might also want to look for any evidence that the advancing questions are pursued by the students. Can they advance? Are there roadblocks? So think about those things as you watch this.
Tell me what you got here.
Here, I know that 6 minus 4 equals 2. And there's the 6, and that's the 4. And then I know that 9 minus 0 equals 9.
Oh, okay. And then what did you do?
And that's the tens and that. I knew that that's the tens and that's the ones, since 6 minus 4 is first, so I know that 2 is the tens, and 9 is like the ones because it was like after it.
But wait a minute. I'm confused now. Why not? How come it's not 2 plus 9 is 11? Because you have a 2 and 9. And seeing a 2 and 9, they can equal 11.
Because we had to subtract it. 69 minus 40. Can't add these two. These two are the answers.
Oh, okay. So can you write another equation for this for somebody like me that didn't understand the 6 minus 4? What would that look like if you, because I heard you say they were 10, so what would that look like for somebody like me that couldn't see it? Can you write me another equation for this right here to show that that's 10s? Okay, I'll come back and check on you. What we got going on? Back to you.
I put 60 tens. I mean 6 tens.
Oh.
And they represent 60. And then we take then I drew 9 ones, and then
And you asked them.
40.
Right, so last time I saw you, this is where you were. So what was the answer that you determined?
I got 29.
And you got 29. What is this right here?
That is Anna's way. She might have solved it, and she might have solved it my way too.
What do you, wait, but you have 70. I thought we had 69, Mark.
Well, yeah, but she could have solved it this way too. 70 minus 40 minus 1 equals 29.
But why would she go to 70?
It would still equal the same answer.
You know, I see this equation right here. I saw that you tried to draw a 100 chart. Why don't you use it and a marker to... Oh, well, leave it on there next time. So redraw it for me so you can explain that to someone else.
So as you watch this next video clip, I want you to really think about how Ms. Tias is making sure that all students are held accountable, and how she's making sure that all students have that understanding.
So what did you do? I knew that 79 minus 9 equals 70, so I just took 30 away and added the 9 to the 30, and I got 49. Yeah. Any questions? Yes, but how did you get the answer? 70 minus 30 equals 40, and I just added the 9. I subtracted from 79, and I got 49.
Do you understand what she just said? So, what did she say she did? John, what did she say she did to the 79?
She subtracted 30.
she subtracted 30, or what did you do first, JC?
I subtracted 9 from 79.
What is that? What is, okay, so she subtracted the 9 from 79. What does that 9 represent? Those are 9 what?
1.
1. So what would that equation look like?
79 minus 9.
Okay, so let's write that first. 79 minus 9.
Equals 70.
Okay, do you all agree?
Yes.
That equals 70, okay.
I know.
Okay, then what?
Then
So, or Markai, you tell me.
she subtracted 30 from 70.
So, John, she said she subtracted 30 from 70. So what equation is that?
70 minus 30.
So 70 minus 30 equals what?
40.
40. All right. But I heard you guys say something about the answer is 49. Where did 9 come back in?
We got it from how much markers you have, how much neon markers you had.
I thought you guys took that 9 away though.
And then I added it to the 40.
Oh, so then you added to the 40 to get what?
Nope. 49.
Okay, you guys talk about that last equation, what you should write.
Okay, again, here's our monitoring sheet. Let's look at what we could do with this during the monitoring part. We're going to be looking for those strategies that we anticipated and maybe writing down some that we that the students came up with that we didn't anticipate. And now we're going to really be like writing down which students are doing which strategy during this monitoring. We really want to see where each of these students are in their understanding of what we're doing. The next practices, we kind of lump together the selecting and sequencing, and you'll see why in just a bit. Okay, so this step has 3 components as well. The first one is to identify the student work to highlight. So you're going to go around and just look at the students and which strategies you're wanting to highlight. Secondly, you're going to really have to be purposeful about selecting the individual presenters. I really tried to make it an effort to give all my students in my classrooms the opportunity to present. So it wasn't the same kids all the time, but I never absolutely required it because some students are just not as comfortable getting up in the beginning and sharing their work. So I would sometimes do things like, well, would you mind if, I shared what you did? Because I think it's so cool. I love what you did here. Or would you mind maybe sharing what you did with little Susie over here? And maybe Susie could explain it. Because I do want them to realize that what they're doing matters and that it's important and it needs to be shared. So I wanted them all to feel that. The third step is after you've kind of chosen which ones you're going to highlight, you need to create this coherent storyline. You want it to flow. You don't want it to be choppy, going from one strategy to another without some sort of organization. So an important part in this selecting and sequencing is to really, first of all, look, you're monitoring all the time, writing things down, and then see which things were maybe a challenge. I liked to choose student work that maybe there were mistakes there, and then they learned from it, and presenting those. And I also liked to think about the difficulty level. I didn't want to just focus on the ones that might be difficult for some of my learners that were still kind of struggling in that area. So I had to keep in mind all of those things as I was choosing which student work to highlight. So in these next few slides, I'm going to be sharing with you the goals that were planned for this particular activity, and then some of the student solutions. And I want you to kind of think about which ones would be helpful or could be helpful in reaching that goal. So go ahead and just kind of take your time going through these next few slides, pause if you need to, and thinking about which ones will help meet that goal. Again, when you are taking the time to choose which student work to highlight, I can't emphasize enough the importance of being equitable and helping those students who might kind of struggle sharing their work to feel comfortable and just create that atmosphere so that everyone knows what they're doing matters. All right, so let's talk about sequencing just for a minute. It really is important to consider what it is you're trying to get with your sequencing. Are you trying to build on a more concrete to a more abstract type of strategy? Are you going to maybe choose it in an order that helps you make connections between the 2 or 3 or 4 strategies that you share? Are you, what is it that you're trying to accomplish, and put them in a sequence that makes sense to you and for your students? You can see here again how the teacher organized her monitoring so that she had it in a sequence. This is who will present first, second, third, and fourth. And she made notes about their solution.
So I think the biggest challenge for me with the 5 practices would probably be the sequencing and the connecting at the end, just because some of them aren't quite there, so I don't want to try to connect it to something that's above where they are, that's higher thinking, but I want to sequence it to get to the goals. So I think being able to select and sequence based on what they're doing, even if it's not on the monitoring sheet, to add it in and to be able to connect it to get all of them to where I want them to be and not confuse them more, I think is my biggest struggle.
Selecting is the practice of determining which solution strategies the teacher wants to have shared during the whole class discussion. In order to make the selections, the teacher needs to review the data they've collected on their monitoring tool and decide which of the solutions and ultimately in what order would best help the students access and make sense of the mathematical ideas that she's targeting in the lesson. Selecting can be very challenging, particularly if you are not clear on what it is you're trying to accomplish mathematically. So selecting must be done in light of the mathematical learning goals that you've articulated for the particular lesson. So it's not about letting 1,000 flowers bloom and letting every student share what they've done. It's about trying to decide which solutions are going to allow you to make the mathematics that you want to put on the table visible for discussion.
The idea of choosing the perfect sequence to be able to open a discussion and how it's going to lead from beginning to end and how are you going to get to where you want to go, that becomes, that's an invaluable thing to try to put together, and it's not the easiest thing to do, so you got to practice it.
Another thing to consider is who will be the presenter. And this is an opportunity for a teacher to really consider which student who produced a particular solution has not had time recently to be seen as publicly competent as a mathematical doer. In this sense, selection can be an issue of equity, making sure that over time, each and every student has an opportunity to demonstrate competence in a public setting of the classroom. Sequencing is really about the order in which you're going to arrange the solutions that are going to be discussed, such that the first solution that gets talked about is one that every student in the class can access. It may be a solution that uses some sort of a concrete model or representation that makes the mathematical idea clear, and it may then build up to a more abstract or symbolic representation, so that what you're doing is you're taking students on a journey. You're beginning with something that everyone will relate to, and then you may be moving to another solution that is slightly more complicated or more abstract. And through this process, what you're doing is you're developing a mathematical storyline. There's something specific that you want students to learn, and every solution that you have discussed provides some piece of information that helps you get to the end game. The sequence needs to build that understanding so that every piece of work that's examined adds to the understanding in some unique way. If a piece of work isn't contributing something different, then there's probably no reason to talk about it. So I think one of the challenges is being clear about what you're trying to accomplish, understanding the mathematics well enough to see how one piece, one solution strategy fits with the next. So one challenge that teachers often face in selecting and sequencing is when you should feature a misconception. So the first thing to think about is that every error students make may not be worthy of having a class discussion about it. But when a student has a missing piece conceptually, and multiple students in the class hold the same misconception, then it's really important to have a public discussion about it so that students can come to understand not just how to get the right answer, but why it doesn't make sense to do it this way.
So our last step is making the connections. And this is one of my favorite steps. My favorite parts of this is when we gather together as a whole group and we can find the way that my students' thinking fits together. When you're making these connections, it really is important to think about connections that connect the student work to the goals of the lesson so that that visible learning is visible, and also how they connect their solutions to each other's. Like, where do you see this in Tommy's work? Where do you see this in Joseph's work? And where's the connection there? So always trying to make connections. So here's an example, like how can we take this work and connect it to both goal 1 and goal 2? As you watch this video, please take some time to think about the questions that the teacher asks to make these connections to the goals, and how do the students' responses kind of address the goals as well.
Let's share and talk about our mathematical thinking of what we're doing. The first person I want to come up is Jocelyn. Jocelyn, can you come up and explain your thinking?
I did 6 tens and 9 ones, and then I exited out 4 tens, and then I still had it 2 tens. So, and then I still had in my ones, so I counted on.
Okay. Can someone explain what Jocelyn did? Tell me what Jocelyn did. What did she do, Audrey?
She put 6 tens and 9 ones, and then she X'd out 4 of 10, and then she got 29.
And then she got 29. But, okay, so then she got 29. But wait, I'm a little confused because I see 6 and I see 2 and 9, but that's 2 and that's 9. Like, how'd you get 29? And then she said she counted on. So can someone clear that up for me? Like, what does that mean, Layla?
It means that she counted on the tens, then the ones.
You guys keep saying that. She counted on the 10. Can somebody show me? What does that look like or sound like? Allison, come up here and use this small pointer. Scoot back a little bit, Jocelyn. Oh, is that correct?
Yes.
Oh, so you just counted by. Now, how you know? Wait a minute. Allison did 10, 20, 30, and then she went 21, 20, 10, 20. What is that counting by?
10.
Or Ray? 10. Why would you count by tens, though?
Because like the tens or tens, you need to count it by tens, and the ones you need to count it by one.
Oh, so then she has 69. Thank you for clearing that up for me. 69 minus 40 equals 29. Thank you. Leah, can you please put your thinking on the board? Show me your thinking.
So what I did is I draw a 69 and then I X'd out 40 and then I counted it and I got 29.
Okay, tell us about your equation. Are you guys good with the drawing? Yes. The base 10 blocks? Tell us about your equation though. Who's wondering about that? Yeah, me too.
So, I know that 6 minus 4 equals 2. And then 9 minus 0 equals 9. And then I know that 2 is the 10th since it went first. And then 9 was the 1 since it went last. And then here I draw 2 10s and then 9 ones.
Layla, can you tell me about her equation? What did she do?
She knows that 6 minus 4 equals 2 and 9 minus 0 equals 9. So she knows that the 2 goes first and the 9 goes last.
What do you mean by the 2 goes first? What do they mean about that? The 2 goes first and the 9 goes last. What does that mean? What are they trying to say? John, what do they mean?
The answer is 29.
Well, okay, I get that. Thank you, John. Sit down. But maybe I should break it down because I'm confused. The 2 goes first. So, London, what is that 2?
10 place.
It's the tens place. Oh, so that 2 is the tens place. So this 2, what is that 2 really? I know she has 6 minus 4, but what is that 2 really? It's what, JC? Oh, can you change that 2 to a 20 so we can see that? Oh, but wait a minute. Class?
Yes.
What do we have to do about Leah's equation if we want to equal 20? So what should we do with that?
16 minus 40 equals 20.
So what I'm hearing you say that her 6 and her 4 are 10s. Am I getting that right?
Yes.
So 60 minus 40 equals 20. And then who can explain what do we do with 20 and 9 to get 29? What do you think we do? You write
20.
it. 20
Plus 9 equals 29.
For the next person I want to come up, Dewan, can you explain to us your thinking? And I want you to explain it as you, yeah.
X 69 and then 40. and I get 29.
Turn around and say it to them.
I X 69 and I have 42 and I get 29.
Somebody re-say what he just said. What did he do? Riley.
He put an X on 69 and then he hopped up 40, then he got the answer 29.
He put an X on 69, hopped up for. Where do you get the 69 from? Like, I'm confused. 69. Where did that come from?
It's your 69 markers.
Oh, it's my 69 markers. Okay, and y'all say he hopped up 40 times. What is that? What is the 40, Leah?
That Miss Gibson took away 40 of your sentence markers.
Oh, and then the answer that he got was, class? 29. So, thank you, Dewan. So let's look at Jocelyn's work and Dewan's work really quick. How do base 10 blocks and the 100s chart, how are they the same? How do they go together? I wonder. To give you a minute to think, practice with a partner. Turn and talk to a partner about how are they the same.
40 from 69.
All right, let's turn back around. 5, 4, 3, 2, 1. So how does Jocelyn's base 10 blocks and Dewan's hops on the 100s chart, how do they the same? How do they go together? JC.
They both subtracted 40.
They both subtracted 40? Okay, but I see the 40 right here, but I don't see it on the 100s chart. Who can help me see that? I don't see where he subtracted 40. Can you? John, come show me where he subtracted 40. So, Oh, thank you. So, John, somebody re-say what John tried to explain to me. Where is the 40 when he did? Yes, Emiliano.
He was hopping 4 times.
So the 4 times must be the what? Talk to me.
40 markers.
The 40 markers that Miss Gibson had. And so that's how those two relate. Thank you. I appreciate that.
And again, after making those connections to the goals, it's so wonderful when you can make those connections between the students' work. So what connections does Mrs. Tias encourage these students to make between the Dewan solution and the other approaches that students have taken previously in their discussion? And how did the students respond? Are they able to make these connections? So were you able to see those connections? And were the kids able to see those connections? And how did that make them feel when they could see how their work or the work of another student tied in? Yeah, I think it's pretty powerful stuff. Well, I'm glad you joined in with me for this pre-session, and I hope you learned a lot about these 5 practices, because truly, I have seen amazing things with this. I've seen this work in kindergarten classrooms. I've seen this work in upper elementary, and I know when I used them myself in even middle school and 9th grade, they were just as powerful. This just gives kids a way to think and gives teachers a way to see our students' understanding and how we can connect them and push them and advance them toward those goals that we're looking for. So give it a try. I think you'll like it.